an embedding lookup of some kind where you all want. And here's an example of what that can do for diffusion, which I think is pretty cool. You can do this on anything. However, oh, my clicker's not working. Cool. This is kind of the application of that in an image sense to give you an idea of how you can do this with text as well. For example, ChatGPT has textual embeddings on the front of it, and people have already taken advantage of those to have it play personas that disobey its own rules, like Dan or Maximus, or there are a bunch of them. That's where you use an embedding to get similar outputs to what you gave it. Really cool stuff. And this last one, I'm not expecting a whole lot of knowledge on it because there's a kind of a moat of knowledge right now around larger FANG companies and like just people who've worked on it. So this is courtesy of Hugging Face. This is the reinforcement learning with human feedback. So here's our ML ops, where you have your language model and then you have a tuned model that is the exact same one. So this presents immediately a problem with scalability for us. So we're moving away from language and going towards memory here. This problem with scalability stems from the fact that, like, if I have generally 1 billion parameters in a model, it equates to about 4 gigabytes on your disk or in your GPU. So if I have a 7 billion parameter model, right, how many gigs on my GPU is that? We're all doing 4 times 7 in our head right now. Right, I'm not even gonna answer. So we got, I'm just gonna let that hang. How do you then deal with the fact that in order to do reinforcement learning with human feedback, you have to copy that whole model and store both of them on disk? There are a couple of different ways you can do this. The one that most companies have opted for is parallelism and distribution of the model, which works. I mean, we see how well it works with a lot of the APIs that are coming out, whether that's Bard or ChatGPT or any of these. There are other ways to help with it too, though. Imagine you were able to identify that only certain parameters in your model on certain layers really needed training for your task. Why do you have to store the whole model or train the whole model? And here's where we get low rank adaptation. You can inject trainable parameters into layers that you identify algorithmically need more training. This way you can decrease the size of the model in your GPU, and you can decrease the training time, and you can decrease all of the effort involved. Very, very cool stuff. But what if that model is still too big for you, right? I'm gonna go over PEFT, and this is hyper networks right here. We have parameter efficient fine tuning, which loads the model 1 bit at a time instead of loading the whole thing at once. And you have hyper networks where you can have a smaller network in kind of an adversarial relationship with your big network to give it to tweak the embeddings as it goes through the layers. And it's involved in that backpropagation too. If you're familiar with GANs, it's similar to those. It doesn't work exactly the same way, but it's similar. All of these equate to something really, really cool where you take a gigantic, let's say that same 7 billion parameter model, right? You have 4 gigabytes at 32, at float 32 weight storage. And this is the last thing that I wanted to share. Quantization, many of you will already be familiar with it, but you don't have to store the weights in that full 32-bit point. You can cut it into 16, and then all of a sudden it only takes 2 gigabytes. And you can cut it into int8, and all of a sudden it only takes 1 gigabyte per billion parameters. And just recently we've gotten it to int4 quantization. So it's half a gigabyte per billion parameters. If you're doing the math in your head right now, you'll see like you can train GPT Neo X, which is 20 billion parameters. It's normally 40 gigabytes on disk. You can train that on one consumer 3090 with 24 gigabytes. That's pretty nuts, right? It's really, really cool. So we're gonna go back to prompt engineering for a sec so you can see where all of this culminates in performance. And I'm really excited to show you guys this. This is from the GPT-3 paper in 2021. I don't know how many of you remember that it actually came out then and not last year in November. But this is evaluating the super glue task, which if you're unfamiliar, GLUE stands for General Language Understanding Evaluation. We have to have a super glue because models too quickly outstripped human parity on glue, and so they made a harder one. And this orange line should be the first one that you focus on. That should be the one that's most familiar to you. That is model fine-tuning. Performance by fine-tuning over and over on the task and by gathering more data and shifting the model parameters to where you think it does the task better, and you can see it plateauing. That's pretty normal. Go ahead. That is number of parameters, yeah. Sorry, here, I'll hide that. Oh, geez. Okay, I think I got it. So second line that you should look at is that blue line. This is the model with number of parameters increasing, doing only prompt engineering. You are literally just changing the prompts that you give to the model. This is not even training it on new stuff. You're only changing how you address the model and how you present the tasks. And you can see way over on the right, you have a lot more parameters, but it is outstripping your first pass at fine tuning. And that should be significant when you're thinking about it. That green line though is my favorite. This is what OpenAI calls prompt tuning, where they are not only doing prompt engineering, but they are fine tuning on the prompt engineering. And they are taking advantage of embeddings during that fine tuning to capture the outputs that they want. So it's a culmination of all three of these ideas in one. And you can see that's the only one that's not plateauing. That's the only one that is coming up towards 100 on the super glue. And for the record, this is how well humans do on super glue. That's a 89.8 average across all tasks. So both our model tuning and our prompt tuning have already outstripped humans on super glue in chat or in GPT-3, which I think is pretty cool. This is where I want to give you guys a lot of examples of this, so you can see, like, this is the fun part where I demonstrate all that stuff. Before I do that, I want to plug really quick. This is me on YouTube. That's my YouTube channel. I go over this stuff fairly often, and I have some videos that I'm coming out with soon. That YouTube link right underneath it is my first tutorial on Stable Diffusion. If you want to watch, I'd love for you to watch. And I want to plug as well, Matt Sharp here. Could you raise your hand, Matt? Matt and I have been asked by Manning Publications to write a book on large language models, and we're going to be doing that. We're really excited. So you'll see these ideas fleshed out in a lot greater detail and a lot of tutorials for you guys to follow along with. Really excited. So let's get into the fun stuff. Right here we have Stable Diffusion. I asked it to give me a fire ghost type Pokemon. Literally, that was the prompt. Fire ghost type Pokemon. You can see this looks almost like it was drawn by a 10-year-old. It's pretty good. You can see the Pikachu references. You can see fire, right? It's a fire type. And it looks like it's on a card. This is pretty good. So let's prompt engineer it a little better. Let's do Masterpiece. Let's add in RTX on. Let's add in Unreal Engine 5. And all of a sudden, it starts looking a lot cooler. Just by changing the prompt, nothing with the model. But let's go a step further and let's take advantage of some textual embedding and let's dream booth it. Let's fine tune it in a good way and do some low rank adaptation. And we get this. How's that for a fire ghost type Pokemon? Pretty good, right? I really like it. Let's keep going with the Pokemon theme. If you're familiar with Scarlet and Violet, there's a Pokemon called Ceruledge that is fire ghost type. It's kind of blue and purple and has swords, kind of nerdy. I wanted to see what does it look like if it had like a dragon type evolution. As this was the first one, I actually dream boothed this first, but just still gave it a vanilla prompt. So this is a fine-tuned model with a vanilla prompt. And this is a fine-tuned model with prompt engineering. That's pretty great, right? Like that looks like it could be concept art. And this is a fine-tuned model with textual embedding and prompt engineering. It almost looks like it's in game. I really like that. And then this one is it's culminating everything. It's a fine-tuned model with low rank adaptation, parameter efficient fine-tuning, everything we've talked about so far. I really like it. I think it looks awesome. It doesn't just work for Pokemon though. I've got one more example of with Stable Diffusion here. This is when I put in David Attenborough in his natural habitat. Pretty good, right? It really got the ear and the face. This is if I just prompt engineer it. And there's a fun bit here. I actually ended up taking David Attenborough, the name, out of the prompt in order to get this image. I described in pretty good detail every single part of this guy's face and what I wanted it to look like. And it came out with it. Like, that looks like him, you know? But this is what happens if I prompt engineer and I use a textual embedding. Looks even a little bit more accurate. And then if I culminate with everything, I add some Peft, I add some LoRa. And you may recognize this from my most recent Stable Diffusion video. If you watch that, I actually have him animated and talking. It's really fun. I think that it's just amazing how we have gotten this far with models like ChatGPT or diffusion models like Stable Diffusion. And most people are still using it in that vanilla stage, considering like what you can get out of it if you push it just with the words, not even any of the technical stuff. So let's go to the next part. How do you guys feel about running large LLMs locally? Here's a demonstration of what I was talking about with quantization, a demonstration of what I was talking about with LoRa and int4 quantization, LoRa, and parameter efficient fine tuning. This is Alpaca running on my Raspberry Pi, which has 8 gigabytes of RAM and no GPU, which that's kind of nuts, you know. Unfortunately, you guys can't read it, but you can see it typing, and that's about how fast it types. It's pretty slow, but it works really well. I really like it. There's this huge bit here shows the model hallucinating, so it's not like it's a perfect solution yet. I don't know if we're going to get a perfect solution very soon, but if you are strapped for the ChatGPT Plus membership, maybe this is something to look for. Here's something that I'm really excited about. So I made this in 2019. This is just a bag of words model that mapped the script of every Star Wars movie and then created a word cloud for that movie. You can't see it incredibly well. I can see it a lot better on this screen. But what I've done is I've come a long way from there and started creating a multimodal large language model. This has 70 billion parameters for Star Wars. So you can see those two images on the right there. That is Luke Skywalker, and that's just create me a character. Those are generated by a language model. It doesn't even do diffusion. It's pretty cool, right? You may wonder how, and the how is a pretty easy question. It's I use the language model almost as an intermediary between various foundational models using Stable Diffusion, where the model essentially, if you're familiar with old dialogue flows, the model essentially classifies intents, but then it has to lead the program from the command line through the intents as it goes. So it did generate that. I didn't generate it. It generated its own prompt for a control net in order to get these sorts of outputs. We talked a little bit about D&D earlier. I have never been interested in D&D my whole life until I've been messing around with this and seeing that like I can generate brand new characters on brand new planets. I can generate stuff that looks like Star Wars The Old Republic, or like Knights of the Old Republic, and I can generate stories that go along with it. I can generate like Revan, how I always wanted him to be, with a huge old arm cannon lightsaber, which I think that's kind of cool. Yeah, it's incredibly cool how detailed a lot of this stuff comes out, to the point where this is actually generated by the model, somebody that everyone should recognize, Darth Vader, right? You can see some artifacts on his little control panel here, but that's very recognizably Darth Vader. I think that's super cool. And I want to show you my favorite part of this, the reason that I'm actually considering doing stuff with D&D or something along those lines. Check this out. This is generated by the model based on images from a very iconic Star Wars scene. Right? It does video, isn't that cool? It's only 1 second, but that's like 27 frames of an anime version of a Star Wars scene. It's pretty great, right? So let's get to the culmination of these ideas. I want to reiterate for you, why is prompt engineering cool? Why are textual embeddings cool? And why is this whole RLHF LoRa PEFT pipeline cool for us? Why do we need the ML ops on top of linguistics? So this is, again, this is something I generated in 2021. Hopefully the audio's a good volume here. Right? That's not very convincing that that's Joe Biden, right? But I've been interested in another mode that we haven't really been exploring a whole lot recently. That's our phonetic modality, where instead of diffusing between text and images or text and video, we can diffuse between text and audio. So this is something that I've done a little more recently. This is Russell Brand. Yeah. So this is a text to voice algorithm that I've developed over a while that is like, it's a modified version of Tortoise, if you guys have ever used Tortoise. I don't know if any of you would be convinced that that's Russell Brand, right? It doesn't really sound like him. If you know him, he is not American. But the cool thing is, it's just straight text going into his voice. And this has worked well for a really long time. I've recently come up with some new things to use, including prompt engineering, including embeddings, and including our pipeline that we discussed for fine-tuning the model. Now listen to this, and ignore the image. The image is generated. It doesn't look very good. What do you think? Is that pretty good? I think it's really cool. In fact, there's a Cameron over here that he is releasing a company tomorrow, Bunked AI. It's to help you stay safe and not be deepfaked online. So yeah, if you're interested in that, talk to him. But this technology is getting really, really talented. And I'm excited to know that like I'm not like, I'm trying to be humble, but also not be weird. I'm not really smart in this field. I'm pretty smart, but not really in this field. And there's some way smarter people than me that are making really, really cool, talented stuff. And that's pretty much it. I am really excited that I was able to talk with you guys. Thank you again to MX. If we could give Garrett a round of applause. Like, thank you guys so much. Yeah. And please contact me on any of these platforms. I'd like to open it up to you guys right now for questions, if you have any. Oh, good question. So textual embeddings involves putting sample prompts through both your tokenizer and your textual embedder. In diffusion models, that's usually a variational autoencoder, if you're familiar with the VAE. You put a sample prompt through and see what comes out. So you can then create an embedding for a new token that has never existed. Like for the Serral Edge, I used Pokemon ZWX because I'm never going to type that accidentally, you know? And you train that one token and see what comes out as an embedding. And then you train that embedding going through your model on like 3 images of what you want. 3 is the minimum. I mean, I ended up using 5 because I was a little worried that 3 wouldn't work, but it's cool that it can get that performance on 5, right? And the reason I was saying textual embeddings and Dream Booth kind of in the same sentences, they're really similar algorithms. Textual embeddings are a little bit more lightweight. Dream Booth is where you like wrangle the model and force it to recognize a new embedding. You completely train your tokenizer over again and your embedding model all over again. And you can even add in for diffusion models the UNet that's actually doing the generation of the diffusion. Does that make sense? So it's retraining only part of your pipeline. That's why it's significant. Right? Yeah. That's exactly what I'm hoping to highlight with this, is that there are a whole bunch of people that are super specialized in computer vision or NLP or, time series. And they end up getting like a little bit of blinders on and thinking that like none of these other specializations is coming up with things that they can apply. One of the reasons why I think OpenAI and Google and these larger companies have been able to push ahead in this realm is by connecting those people and having them just try it. Like, hey, this worked out in our computer vision department. Why don't we give it to the language people and see, like, can you make it work? And generally it has, and that's really cool. Go ahead, Eric. Yeah. Well, I'll tell you, I know that like if I know about LoRa and PEFT, like they're already using it. If you're wondering about how OpenAI was able to decrease the price of GPT-4 to like 1/10 of what ChatGPT was, it's because of that. They're optimizing it. As far as what do I think they will do in the future, I think that the moat of reinforcement learning in language modeling is going to keep getting bigger because people are used to GANs. They're used to that adversarial sort of paradigm for it, but this is tandem working towards a reward with proximal policy optimization. And that is like, it's hard to understand and it's giving them kind of a tech edge in this area. I think that's going to continue. Go ahead. Yeah. Yeah. I like that. Yeah. So when I started getting into this, I started using set tokenizer vocabs for it because your tokenizer vocabulary comes pre-trained with whatever model you're dealing with. And basically just went from there. I went, what are the scalars? What does the vector look like that comes out of the tokenizer, and realized, it's splitting words in places that I never would have split those words. I didn't learn that that's a prefix when I was in high school, but the model cares about it. So why don't I try just putting that through by itself and see what comes out the other end? And you don't have to do it by hand like what I'm describing. You can do it algorithmically. Pretty cool, right? I really like what you're saying though, because in that programming language theory, decreasing the subset actually adds ambiguity in linguistics, which is kind of fun. Many of you have seen The Office, the why use lot word when few word do trick, right? See world, right? Your subset is really small and you have semantic ambiguity immediately because of the small subset, right? And so the prompt engineering is exactly as you described. It's trying to reverse engineer that ambiguity that was created as we're abstracting these terms. Yeah, you did. That's a good question. Oh yeah, there are tons. So that's a fantastic question. I'm glad you asked. So naive Bayes is something that a lot of people still consider to be a baseline for language modeling because it is so accurate on so many classification tasks and it's fast. It's easy to implement. It's really cool. No, you do not have to use naive Bayes, and there are dozens upon dozens of improvements. Even the n-grams that I was talking about, we didn't get to that, but one of the reasons n-grams is a problem is because your vocabulary ends up exploding. Like if you do quadgrams, it's already gigabytes. But you can keep following the progression of things. Naive Bayes is from 20th century. If we want to go into like 2016, 17, we have the advent of the long short-term memory, the first language models that we're trying to keep track of sequences, sequence models, and then you have BERT, you have GPT models, even GPT-1 is one of the papers that I had in there. And we get to the bigger ones like ChatGPT now. There's been a really cool progression to watch, and it's really fun to keep track of. I'm glad you asked. Thank you. Go ahead. Merging model weights. Could you explain what you mean by that? Okay, sure. Yeah, the web UI. Cool. That's cool. I haven't even tried it. That's really cool. That sounds like you're trying to get a job in graphic design, right? I can just merge whatever I want into this big old monolith model. That's super cool. I really like it. Any other questions? Go ahead. That is a really good question, and it's going to depend entirely on your model pipeline. So if you are a BERT encoder-based pipeline, I'll use that as an example. A lot of people really like BERT. You're going to want to go algorithmically, again, based on the outputs that you're getting from your model. Right? If you find that you just give BERT a vector to classify, and let's say it's just a binary classification, positive, negative, you want to look at what comes out, and you can use, I think there's a BERT explainer. There are a lot of different explainer modules so that you can analyze individual tokens and start to get a good sense for which tokens the model considers to be really important in determining the outcome. And then you can design prompts around either using or not using those tokens. Sometimes it doesn't like coincide, like I said, with our human vocabulary. A good example with BERT is abhor. Abhor is a word that I tend to think is really negative, right? It's like to really hate something. But BERT as a vanilla model ends up determining that as like a really strong indicator of a positive sentence, whereas abhorrent is negative. And like knowing that knowing just that one little piece of dichotomy, you can then start to like create a prompt or modify already existing prompts. Like if you're working with a data set already, you can modify your data set to get what you want and to get a really strong confidence out of it. This is especially effective during training, right? Because you want to be confident in your inference at the end of it. Does that answer your question? Is there more? Cool. Yeah. You're asking questions that nobody's solved yet. Look at you. The way that a lot of people have been getting around this is by giving the model context beforehand. Like if you've interacted with the GPT-4 model at all, it has a whole separate space for you to input context for the model to behave in. Like you are a lead programmer who is helping me figure out the best way to use Python right now. You can give it that context and then it will use that context to help determine what's the best answer. But no, there's like that's unsolved. We would love to be able to insert pragmatic and semantic knowledge, just like inject them into our models, and that's really difficult. All right, if that's everything, thank you guys so much.
I was going to say, so we're hiring data scientists, and the lights just turned off. Does someone want to hit the button, the white touch button next to the